Okay, hi and good day everyone. So today we're going to continue on Quarters 2 software, right? So please open your Quarters 2 software. So once you open, you should be able to see the view as what we can see now. Okay, we're going to create a project, okay, to design a 4:1 multiplexer. Okay, so in this demo, we're going to explore different way of write different way of writing Verilog HDL code to implement the same hardware, which is the 4:1 multiplexer. So we have three types or three ways of coding. So we start with the simplest one, okay, but it's error prone one, which is the data flow based coding, right? So before that, we need to create a new project, okay? So just follow the steps, create a new project, okay? Next, and then you can choose folder location, right? You can browse and then choose which folder location that you want to save your work, okay? For example, you want to create a new folder here. So you just uh, create new folder, okay? For example, name it as your code mj32303 and select this folder, okay. And let's say you want to create another folder, you can also write this way, okay. For example, um, marks 4:1, for example, name, okay. And then name of the entity or of the project, okay. This one is the folder and then name of the project. So let's say marks 4:1 as well. So the same one, for example. Okay, then next, and then this will pop up and then asking you whether you want to create the folder marks 4:1 or not. So you just press yes because we want to create that folder. And then if you have any file ready with you, you can add. So in this case, no, and then press next. And then target device. So this is actually you can select the device straight away or you can leave it as it is. Okay. So for example, you want to select the device. We are going to use Cyclone 2 FPGA, and the device number is EP2C70. So you go find for C70, EP2C70. Okay. I think this is the device. Okay. Right? So with almost 70K logic elements, right? So and then next, okay, so you are going to use Verilog, and then next, this is a summary, your project name, your top level design entity name, okay, and then you finish. Okay, now we have the project. We not yet have the what we call the design file. So what we need to do is actually to create the design. So click on this one and then choose Verilog as a design entry or design file, and then you write OK. Now we start coding. So for example, we start with the data flow. So data, so we put a comment so that we can trace it easily. So data flow type of design 4:1 design. Okay. So remember, line number 1 is a comment, so it will not be evaluated by the compiler. Okay, now we start our coding. So remember, we have module at the first and then and module. Okay, so module, so give your module name. So your module name has to be the same as your entity name that you're going to save. So this is a Verilog number 1. we not yet saved that file. So when we save it, make sure it's the same name as the design entity name. Okay, for example, its name is marks 4, okay, by 1, for example. Okay, and then we open and close bracket to list all the input and output involved. So remember, so we have what we call multiplexer. So maybe I can sketch something on multiplexer. So this is our multiplexer. Okay, we have 4 input multiplexer, and then we have 1 output. So that's actually the hardware that we're going to implement. So we can label the input first. For example, the input here is D3, for example, D3, D2, okay, D1, and D0. So these are the input. So let's say the input is 1 bit each, okay, and we remember we have to have another input, which is the selector, to select all the 4 input. Okay, so input number 3, 2, 1, and 0, or equivalent decimal is actually this one 0. Sorry, this is 1 1, 1 0, 0 1, and 0 0. That's actually equivalent 2-bit binary value. So how many bit for this selector? So definitely 2-bit lah. Okay, because we need to have 2 to the power of 2 possible combination, which is 4 possible combination, which is 0 0, okay, 0 1, 1 0, and 1 1. So this is actually the possible combination of input. So if we get the equivalent decimal value, this is actually 0, 1, 2, and 3. So 3 here is actually this one, right? So that's why we need to have at least 2 bit. We can have more than that, but it's not worth for our design. 2 bit is enough. All right. So how about the output? So the output also 1 bit, and the name of the output is out. Okay. Out. Okay, this is actually the hardware that we're going to design using Verilog HTML code. So back to the code. So remember, we have the input. Okay. So maybe I can make it side by side so that you can see it clearly. So this is actually the diagram of the multiplexer. Okay, you look at the multiplexer, and then we write the code side by side so that we can see it clearly. Okay, so I try to make it visible. Okay, make it bigger maybe. Right, so hopefully everyone can see it. Right. Okay, so now we start write the coding. So now we specify the input first. You can also put a comment here. So input. Okay, and then we also specify the output. Okay, to make a comment, just use the 2// right? So now we start with the input first. So input, how many input we have? So 4 input with 1 bit and 1 input with 2 bit. So we need to declare the input separately, okay, for the 1 bit and the 2 bit. Okay, now we start with the 1 bit input first. So input D1, D2, D3. Right, okay, oh sorry, D0 first. D0. This should be D0. Sorry about this one. This should be D0. Okay, D0. Okay. Now we finish about the input with 1 bit. Okay, we put comma in the last, and then we declare another input with 2 bit. So 2 bit is actually 1 to 0, and then that's actually the bit width followed by the name of the input, which is the cell or selector. And now we finish about the input. We move to the output. So output only one bit. So output, we declare the the direction as output, and the name of the port is out. No comma at the end of the declaration. Okay, so you finish declare the input and output with data type and also with the size of the bus. Okay, so if you can see here, line number 5, number 6, okay, and number 8, we didn't specify the data type, but by default it is wire data type. Okay, finish about the declaration of input and output and data type, and then we move to the design, okay, of our marks. Okay, the data flow base design of the 4 to 1 marks or multiplexer. Okay, we start coding by using assign statement. Okay, assign, we assign output equal to D0. Okay, and with, this is actually tedious task because you need to remember the type of the signal and also the notation of the signal. Right, so I try, right, shell, okay, shell, and then 1, then n, and then underscore cell. No, underscore, this is tilde, it's inverted version of cell actually. Okay, this is actually, it's taken from the Boolean operation actually, this one. You don't have to worry about this. I just want to show you or to demonstrate actually the what we call many ways to do the coding. Okay, and then you at the end you choose which one is the easier and the best way, right? Okay, and then we put OR gate here. Okay, and here is AND gate. Here is actually inverter gate, and this is AND gate. And we have OR. Okay, and then we have so always use tab to make your coding readable. So then V1, maybe I can edit from here, so it will be easier and avoid from error when you do the typing. Okay, so this is V1. Okay, V1 and cell 1, and also cell 0, but in this case now we don't have the inverter. Okay, and then we do for V2 cell selector. This is selector 1, and with inverted version of the selector 0. Okay, and then the next one or the last one for D3. So D3 we end with the selector without any inversion, and as well as this one. So now you can see the pattern, right? So inverted selector 1, inverted selector 0, inverted selector 1, non-inverted selector 0, non-inverted selector 1, and inverted selector 0, and both non-inverted selector 1 and non-inverted selector 0. Okay, this is actually the algorithm or equation that to implement the multiplexer, 4-to-1 multiplexer. So at the very end, we don't OR them, we just put semicolon. This is actually what we call as statement terminator. Okay, statement terminator. So it will terminate the statement so that your compiler knows the end of the assignment, signal assignment. So now we already completed our code for the multiplexer. Okay, so now we save it save the file. So make sure it's the name same as a design entity, right? So you click save, and then okay, make sure you have that name same as your design entity, and make sure you add it to the current project, and then you save it, right? So you can now start to the compilation to check whether your code is error from free from any syntax error. So this is actually the button, okay, shortcut. Then you start compile. Okay. So if you're lucky enough, and then you have no error, right? Okay, you can proceed to the synthesize and see the RTL view. So you can keep your eyes on this. Go to this one and see you have 12 warning without error, no error. Okay. So this is the error tab. Okay. If there is any error, it will mention to you. Okay. So in this case, no errors. And the warning is actually not related to your design. Okay. It's only mentioned about the other non-important warning. So you can ignore it during this stage. Now, okay, you like to see the equivalent RTL of your design. Okay, you go to the full design flow window here, and then we already compile, and then we already analyze and synthesize. Means that it's already translated to the equivalent hardware. Okay, now we go to the RTL view to see the hardware. So this is actually the what we call as the multiplexer. So we have 4 input, D0, D1, D2, and D3, and then we have the gate inside. Okay, we have the gate inside that implement the multiplexer. All right, so this is actually gate level representation of the um, multiplexer, right? Which is the lower level than the data flow level like this one, right? So this is the equivalent, which is almost equal to, which is equal to the hardware that we plan to get, right? Okay, so now let's say we want to try another way, okay, to do the coding, okay. So I will stop first so that you can explore this, and then we continue on next video to see how to um, do the second design of the multiplexer. Right? Thank you, and please subscribe the channel so that you get the update. Thank you.